so here we have an example of an elastic collision, and I've copied over the results that I just talked about in the previous video, which was taken from these two slides. So if you haven't watched that, please go ahead and watch that first, and we're going to use that result to set up this problem. So in this problem, you have a proton that's traveling to the right at 1.2 meters per second, and it is headed on a it has a head-on perfectly elastic collision with a helium atom. The mass of the helium atom is 4 times the mass of the proton. What are the speed and direction of each after the collision? So let's set up the problem. We have a proton that is coming in with some velocity that is 1.2 times 10 to the 7 meters per second, and it is colliding with a helium atom that is sitting here at rest. And then after the collision, we'd like to know what is the direction and speed of each of these. So in terms of using basically these results from for general elastic collisions, what's happening here? So before the collision, let's say that the proton is going to be our particle A and the helium is going to be our particle B. So we can set mass of particle A equal to the mass of the proton, and then mass of particle B is equal to mass of the helium atom, and we've been told that that is just 4 times mass of the proton. So we can set MB equal to 4 times mass of the proton, and MA is just the mass of the proton. Additionally, we know that before the collision, velocity of A, which is the velocity of the proton, is 1.2 times 10 to the 7 meters per second. And then the helium atom is starting at rest, so that's basically our particle B. VB is 0. And after plugging in these values, pretty much what you're being asked to find is VA prime and VB prime. VA prime will be the velocity of the proton. Proton after the collision, and VB will be the velocity of the helium atom after collision. And from here on out, it's just a matter of plugging in the appropriate numbers that we have here. And note that even though we're not given the mass of the proton, you will not need to know what the mass of the proton is. This MP factor will drop out everywhere it appears, because basically for MA, when you plug in MP, for the MA plus MB, you're going to be plugging in MP plus 4MP. So you're going to have a common factor of MP everywhere. So the mass of the proton drops out. You could look it up, you could plug it in, but let's say this problem was given to you on a quiz without being provided the mass of the proton. You should know algebraically why it actually doesn't end up mattering and how that factor drops out.